70% हमारी बॉडी में 70%
Good afternoon, everyone.
Good afternoon.
I hope you are enjoying the course, having a good learning experience. So this particular session is regarding your doubts. For whatever weeks we have been the live contents. And so Professor Sandeep and myself will be answering to your doubts. You can keep posting your queries into the chat box and we will take up those. So from the earlier from the discussion forums, there are certain questions which we will take up until I get more questions in the chat box. So it has been asked about the difference between hydrogen fire and explosion. So I will suggest you have to little wait for longer because we are discussing more in details what are the causes. In the hydrogen safety part, just to give a very brief, it is something after a chemical reaction which releases a lot of heat, increases the temperature, results into the fire. It's like a sort of combustion. Explosion is a sort of physical phenomena wherein building up of high energy due to temperature rise, increase in pressure, leads to loss of confinement. Then it is an explosion. But more details you will be able to understand when we will talk about the hydrogen safety, which is the last section of this course.
And just to add one point, so you can sort of relate the fire and the explosion with just your Diwali crackers. In the Diwali crackers, most of the crackers will have the same chemical. So you take, say, a flower pot anar or chakri or anything like that which burns slowly. It is actually a fire. That is also the same fuel burning. But now, as Madam said, what is explosion? Then you relate it to any bomb, any Diwali bomb. You have confined all the chemical inside a small chamber. And when you ignite it, it burns. It also creates fire, but the gases are not getting any space to move out. And suddenly, a lot of energy will release because explosion is because of the high pressure accumulated and then it will just explode. So in fire, mostly you will get heat and light, but not a pressure or the lot of wind or this thing or the push of air around it. But in the explosion, lot of energy released from a small confinement because it is not able to escape. So it will just explode because of high pressure. So that is a simple thing. Fuel will be same, but the phenomena will be little different.
So the another question being asked is about the demand of green hydrogen and its cost, concern about its cost, which is not still viable. So this is so this particular field, if you see hydrogen and its adoption in industries or widespread adoption, will be governed by many parameters. And globally also, you could see that its adoption is increasing. But there will be policies from the government that will definitely is going to support. And also you have seen the in India also the National Hydrogen Mission with incentivizing the manufacturing of electrolyzer or green hydrogen production. They will make ways, and similar policies are there globally, worldwide in different countries that will increase, that will decrease the cost. At the same time, there will be mandates which will be required for utilization of that green hydrogen in different sectors. That will increase the demand. Maybe Sandeep, he can add more.
Yeah. So actually, when we look into sort of a demand of green hydrogen and increase, means still sometimes you can, again, I will try to relate it with some other technology. Just 20 years back, nobody has thought that solar photovoltaic will become so cheap and so widely sort of used. Now, but this is one of the cheapest way of producing green energy. But 20 years back, that was not the thing. So sometimes you put lot of effort in your R&D and your manufacturing process, your overall mass production, when it reaches a critical point, it becomes economically viable. Some of the technologies are like that. Same thing happened with solar photovoltaic. Same thing we are expecting with lithium-ion batteries. You can see the price of lithium-ion batteries, which was 10 years back, 5 years back now, and what is projected for next 5 years. Same thing we expect for hydrogen. So hydrogen has multiple components. It is not only green hydrogen, the gas. It is a production system, utilization system, and also storage system, transportation systems. All those things, lot of effort, R&D efforts, manufacturing, mass scaling, everything is going on. And sometime initially they need support, and that is what the government policy is doing. And then we are very much hopeful. We are very much hopeful that once we will trip over that critical point, just like we did for the solar photovoltaic, and maybe in many places, lithium and battery has already done over the IC engine vehicles. So that will, we are hopeful that will happen with the hydrogen technology also. Okay, so next.
There is a question. What is the maximum efficiency of hydrogen combustion achieved till now?
What is the
maximum efficiency of hydrogen combustion achieved?
Okay, so actually it is not the efficiency when we talk about the combustion, because when we do the combustion, it is about the utilization. So say we have a hydrogen, we just burn it to get heat. Just like you say, the industry needs heat for various process, and they use natural gas, they use diesel, they use coal for heating process, and now they want to shift to green fuel, that is hydrogen. But that will be like a combustion, like a burner, just like your LPG stove. So your wood chulha or wood stoves are like 15-20% efficient. Your LPG is like 60% efficient, but that is because you are keeping in an open thing. You are cooking it over an open cook stove. So you get around 60% efficiency. But if you look the same combustion system into an industrial setup where you create all the heat recovery systems, you make it enclosed combustion so that as much as heat you are able to extract, you extract it, you may get even 80-85% efficiency easily. So that is one part. But other part of combustion is in the IC engines or the sort of power systems. So in the IC engine side, so recently BMW and General Motors and many other companies have been working on it. BMW have got more than 35% of efficiency, thermal efficiency, which is even more than diesel. So they have made hydrogen IC engines which are more efficient than the diesel counterpart. So we are hopeful to get a more better system than that. In the turbines, it is a little less efficient. In IC engine, it is a little more. In the normal thermal application for like a burners or something, it is as good as 60-80% we can achieve. I hope it's clear.
Ma'am, next question is from Jay Chaudhary. He is asking about photoelectrochemical reaction related to conduction and valence band of materials.
So this is like if you photoelectrochemical processes, these are if you try to have the mapping, in that case it works like a semiconductor device. So wherein the difference here is like you have an your electrochemical process, and the energy required is like coming from the radiation. And what is being done is like your separation of water. And then because there will be a potential that will be required for this separation of charges or your splitting of water. So as such, there are different materials which, based on their valence and conduction bands, some of these will be suitable, some of these will lie in a particular range, which are acceptable for photo. So that these numbers we have studied in the lectures. If those particular materials have a band gap or valence electron and your energy band diagram as per the requirements for that particular reaction, in that case, these are considered to be suitable for such processes. However, those lying beyond those windows, so they are not considered good for photoelectrochemical processes. And those details, what materials like TiO2 is one of the material. These materials have been discussed in that lecture.
The next question is about Contribution of thermal energy and electrical energy in water electrolysis. What is the significance?
So actually, if you see the required energy, the total delta H value that could come from either, so you have two contributions, delta G and T delta S. Now, total energy which is required for electrolysis, that can come either entirely from electrical energy, that is like electrolysis process, which is your room temperature electrolysis or low temperature electrolysis, we can say, or it can come, most of it can come from thermal energy, because we have already studied that completely from thermal energy will require very high temperatures, which are not feasible to be used. So it can partially come from electrical energy and partially come from thermal energy. Now that particular contributions will define the electrolysis process. For example, if it is low temperature electrolysis, the thermal contributions will be very less compared to the electrical one. So the major input energy will be electrical energy or the electricity input to perform the water electrolysis. However, for high temperature electrolysis, like your solid oxide electrolyzer, in that case, the waste heat can be used, which will be a high temperature heat for providing that required energy for electrolysis. Now, if it is high temperature, maybe 500 degree and above, then the requirement in terms of electrical energy will reduce. So, in fact, that depends upon what is the process you are using. Partially, it can come from thermal energy, partially, it can come from electrical energy, depending upon if there is a waste heat available, what is the technology which is being used. Accordingly, this can be decided.
The next question is regarding there's a natural gas, a CGD company. What is a typical average consumption of methane per day for a brown hydrogen production plant? Brown coal.
Yeah, so actually, I would say that the question is a little incomplete, because when you say a typical average consumption of methane, then we also have to look into what will be the capacity of the hydrogen production, because it will be directly linked to the requirement of the hydrogen. So when we look into the brown hydrogen production plant, you can say that typically on a mass scale, all the processes are being followed to capture as much as hydrogen present in the methane, and also some contribution comes from the steam that goes into. So you have, like, typically every methane will have 2 moles of hydrogen, but when you react it with steam, then you will have another mole of hydrogen present. So, and carbon monoxide, which gives you hydrogen basically from the steam methane reforming, not steam methane, the water gas shift reaction. So typically you get that much, and almost I would say that on the reaction side, more than 90% of the hydrogen is recovered. And then comes the separation part. Then depending on the separation, and again, if it is a big plant, typically they go for PSA, and that also has a good recovery of more than 90%. So typically you can assume that with that level of hydrogen, whatever is present in methane, almost more than 80-85% is available as a product when you go for a bigger plant.
The next question is regarding how will storage and transportation of hydrogen will be viable from a materials perspective? Would it be better to focus on green ammonia?
This question will be very descriptively answered when you will go through the remaining part of this course, which will be on storage, wherein we will be studying the 3 different ways of storage, which is compressed, liquid, and solid state storage. Besides that, towards the transportation section of this course, we will be also studying different ways of transporting hydrogen, whether it is liquid in the form of liquid hydrogen, liquid organic hydrogen carriers, like ammonia or methanol, or via compressed gas in the form of pressurized gas through pipelines or tankers or trailers. So all this will be answered when in the later part of this course. So these are different ways. And compared to ammonia, so herein there are 2 decisive parameters that will decide on which one to be selected in terms of transportation, whether it should be liquid organic hydrogen carriers or ammonia or liquid hydrogen. And that parameters are in terms of distance as well as how much quantity you want to carry. So once we are into that particular week, you will understand that till a certain distance, one particular technology will be economically viable, and beyond that certain other technology takes over and that becomes more feasible. So I would suggest that you will, once you go through that particular week, I think you will be able to better understand that.
The next question is regarding, apart from electrolysis process for green hydrogen production, which are the other technologies which are cost competitive and scale to a commercial scale within India?
Is that for green hydrogen only?
Yeah, green.
So we have, so that one technology also we have studied in more details is a thermochemical hydrogen production. A lot of work is being done in that field as well. A lot of cycles also we have studied in this course. In several premier institutions are also working towards that particular method for green hydrogen production. Besides that, in India, hydrogen production from biomass till a particular level of carbon dioxide emissions being considered from biomass is also being considered as green hydrogen. So this is 2 kg of carbon dioxide per kg of hydrogen is the norm which is being set by Indian government. This is a maximum amount. Until then, it is also being considered as green hydrogen being produced.
The next question is regarding why hydrogen shows reverse Joule-Thomson effect. And if we think in that perspective, if we send compressed hydrogen to low pressure tank in vehicle, it can induce problem of heat.
So actually all the gases they show, so there is an inversion temperature. I think we will have to go back to our thermodynamics things and we will have to study. So that is there for all gases, only that what is the inversion temperature that decides on to till what temperature we can use that with a Joule-Thomson expansion or your porous plug or your throttle valve. So we have to cool down to that temperature so that it produces a cooling effect, not a heating effect. So that is the requirement when it comes to liquefaction of hydrogen. So when it a compressed hydrogen, it is being filled into the tank. Yes, it is correct. So when it is being filled, always there is a heating effect. And there are norms standards also. There are SAE standards that you have to cool it down to a certain temperature when you fill into a tank. And all those details will be there when we will talk about standards in the end of this course. So codes and standards. So you have to cool it down. Definitely it has to be cooled down to a certain temperature while filling.
The next question is regarding, is there any defined temperature profile that exists along the length of the electrolyzer? Because each cell has different temperatures.
It's not a defined temperature profile. See, this will depend upon many things again, because there are the stack size will determine, because how many cells you have combined and under what conditions you have kept, what is the heat loss that is going to take place, what is the coolant flow. So there are many things it will depend upon. And that also will vary from not only the technology, but also from the, so there will be different technologies which will have a different, like as mentioned, PEM will work at 80 degree, however, the SOEC will work at 500 or beyond. So these things will vary. It's not a defined temperature profile. What is the capacity? How many cells are there in a stack? Under what conditions it has been kept? However, it is required that the temperature should be better. It should be uniform, because then the degradation. So there are degradation also associated with components. So in that case, it should be better homogeneous. But again, it is not a defined one because it varies.
There is a question from Saurabh Pandey. He is asking, can IIT Bombay support for the manufacturing of hydrogen electrolyzers?
At IIT Bombay, we have faculty members who are working on the electrolyzer side, different components of electrolyzers, on stack as well, stack development. So we are working on different aspects, whether it is catalyst, whether it is membrane or electrodes, as well as how we will, what will be the flow fields, what will be the gasket, what will be the plates, bipolar plates, assembling them together, making a stack. So we have different people, different faculty members who are involved. They have research teams who are working at IIT Bombay in these areas.
And why are we calling natural gas as a methane?
I think Pawan Kumaran has already answered. So I think That's the correct answer. So, because natural gas has methane as a major constituent, more than 92% is methane. So, technically, naturally, it is called natural gas because it is available natural, but chemically, it is mostly methane. So, we call it methane.
Then whether hydrogen mixing is allowed in city gas within distribution network at present in India, like bio.
So actually, it is in pipeline. I won't say that it is already implemented in mass scale, like we have this bioethanol mixing in petrol, but it is in the pilot scale. So government has given a sort of a what you say mandate to test 5% hydrogen mix in the PNG or the pipe natural gas. So pipe natural gas, it has been started. So what information I have, it could be in many other cities, but in Indore, it is in pipeline. So they are testing it. So once you add 5%, so then it will be evaluated on the material of the pipeline. Does it has any impact on the safety side, on the home usage, whether it is safe to use, all the safety measures are which are designed for PNG, or it is okay with hydrogen and PNG mix. And on the other side, the vehicular use. So typically on the global standards, 20% hydrogen and 80% natural gas or the CNG, compressed natural gas, and 20% of hydrogen in it is as good as your as good for the CNG engines for the for the 100% CNG. So your tanks, your engines, and your filling stations, they can very well manage with 20% hydrogen into it. It has been tested and standardized on a global level. But when we look into India, we are still, we don't have enough hydrogen actually. So we are not following it, but maybe in the near future, you will see that happening soon.
The next question is, like, as per gas cylinder rule of 2016, every compressed cylinder should undergo hydrostatic testing after every 5 years. So how cylinder will test which is fitted as a fuel tank in vehicle?
So this is already being done in like when it is your CNG tanks. So after every, so there, the certification is
5, it's 3 years.
3 years. After
3 years.
every 3 years, you have to get that tested. And then that stamp has to be revised for the, like this has been tested on this particular date. And until and unless you do that within that time period, your filling will not be done by the refueling station. So that is already in practice for CNG.
And what are the measures available to handle hydrogen as a fuel, as it is highly explosive and propagates very fast?
So when it comes to handling hydrogen as a fuel, it has different applications and different sectors also. So we should remember that we have been using hydrogen as an industrial gas for decades, 50, 60 or even more than that years. And in industries, in the confined environment, within the periphery of that industries, we have been safely handling, and we have a lot of industrial experience in handling these hydrogen as a fuel, as a reductant, and various applications. So it's not new. It is only that it has come out from the periphery of the industries, within the industries, to now for usage into the public places, including your onboard vehicles as well. But we have hydrogen, when it comes to being used in, let's say, for fuel cell electric vehicles, all the safety norms are there. Without that, nothing will come into the commercialization stage. So there are sensors, there are walls, there are systems which will tell you that, okay, this needs to be corrected. Also, other than that, when it comes to tanks as well, they have to undergo very rigorous testing, which is as per the international standards. So it is not that we have handled in industries. But the thing is, now when it comes to being usage for a layman or into the commercial vehicles, in that case, already there will be all safety features which will be there. Until and unless these have 100% safety features being incorporated, this will not come to marketplace. And then all the testings are done before, so as to consider all worst case scenarios as well. So, for example, if it has to operate at a pressure of 700 bar, it has to be tested at times, maybe 2 times of pressure so that it does not, even in case of impact, it should not rupture. So there are many testings which are to be done on these tanks before these are installed onto a bike.
There is a next question which asks, like, there are few membrane-less electrolyzers. Why they are not considered to be viable when we compare it to PEM and alkaline?
See, it's not that. So if you see, like in case of in the field of batteries, starting from lead acid, then we have made a move now mostly lithium ion, and then now people are talking about even sodium ion or other battery technologies. So it's not that we are ruling out all these technologies, it is in a progressive stage. So earlier, like most of the electrolyzers were alkaline, but based on the requirements for mobility sector, PEM was found to be better. Now, so this is an evolving field. It is not that we have ruled out any new technology, but there are different technologies. Depending upon their pros and cons, these will be adopted in different fields of applications.
Can we consider PEM to be most dominant electrolysis technology when intermittency is considered?
Yes, because even if there is a variation in the load or the power onto the input power side, it gets tuned or synchronized very easily. So PEM is considered to be more adaptable when there are variations or intermittency that is there.
How to get natural gas?
Dig a hole in the earth, you will get natural gas. So yeah, so means it's more of a mining and exploration thing. Naturally, it is not available out above the earth until unless you see biogas as a sort of a natural gas sort of a thing. But fossil fuel based natural gas under the earth, you have to go and get it.
So there's a question from Maran. Hydrogen is not an energy source. It's actually a energy storage medium. Compared to other kind of a storage devices or medium. Why we need to choose hydrogen for storage purpose?
Actually, you are right in some part of it. Like hydrogen is not an energy source. Yes, that's why it is called as an energy carrier. Now, why we are looking for hydrogen? This is because we have already identified the ill effects of the greenhouse gas emissions, and we are now all worried about the climate change problem. So now the move is required because see, if you see from wood to we have moved on to hydrogen. So the carbon content in the fuel has gone down. It was wood initially or coal or your gasoline, diesel, then methane, and now hydrogen. So it don't have a carbon atom into the formula. And I think.
Yeah, so just to add it, so the need to go for hydrogen is basically, though we are getting hydrogen from some other source, but expectation is that we don't get hydrogen from the carbon source like natural gas, or at least if we get it, the carbon should be sequestered or captured back. But the focus is if we get a lot of green electricity, which is quite possible, that we have a very cheap solar and wind available throughout the globe. And if we can convert that to hydrogen, then hydrogen can fulfill or fill those gaps where electricity directly can't do the job. So we can use hydrogen as a fuel wherever natural gas or diesel, petrol, or coal are used. There, hydrogen as a fuel or a chemical can be used there, and rest of the places electricity can be used. So that is a sort of an overall philosophy. Just to decarbonize the overall energy sector, we have to look into the gaseous and liquid fuel where hydrogen can act as a substitute.
There is a question. Is there any issue regarding ramping up the electrolyzer? And then how do we solve that issue? Because it will take much time to reach the full capacity.
Issues related to ramping up of electrolyzer are, so actually if we go back into the history, we even before SMR, we were using electrolyzers and there were megawatt size of electrolyzers. Even in India, we were using those. But what happened was with SMR becoming more efficient and cost effective, that technology, it was not used for quite some time. Now the problem with the major electrolyzer, let's say for PEM, we have certain problems related to the cost, which is coming because of the use of precious metals. So your membrane electrode assembly. So what is required is, with the economies of scale, we will see the cost decrease. Now, ramping up of electrolyzer, that is what is being required definitely, and different governments are proactive in taking the initiatives to increase the electrolyzer capacity. There are different targets which are being announced. So what is required is definitely to see the economies of scale, bring down the cost. Now, if it comes to particular countries, then the components development is seen as a problem. At times, there are certain components which are required. Now, with the increasing, it's like with the major players in electrolyzer, it has also been seen that there is a huge demand which is coming up, and they have to increase their production capacity. So, also at the same time, the demand, where is that hydrogen to be consumed, that also needs to be created. So it will take certain time with proper strategies at place that will see an increase in the capacity of electrolyzer with time.
Whether hydrogen can be produced from CBM, which is available in India in coal mines.
Yeah, so actually there is a big project going on, which is a coal bed methane and also sort of a coal gasification. Coal bed methane is a sort of you can say a better way of capturing it and converting it to hydrogen, because it reduces the increases the safety aspect inside the mine, because it's a flammable gas. If we capture it, it's better. But once we capture it, because it's quite a highly greenhouse gas compared to CO2, so it's better to convert it into some other form. And if we can strip out hydrogen from it, then it is quite good. Only the issue is like the coal bed methane is not as pure as we get the natural gas. So the economics is not supported. So the only thing is like the economics, because it will be mixed with the air. It will have few percentage of methane with lot of nitrogen, oxygen, and CO2 in it. So that we have to see, but it's not, the technology is not there. Only thing is the economics doesn't support it, but definitely it's being looked into. Other aspect is converting the coal, because it's a lot of coal we have. India has a reserve. So rather than burning the coal for generating electricity, we can use the same coal for hydrogen production through coal gasification, combined with whatever the coal bed methane is there, that will also add into it and generate hydrogen. So these are in pipeline, but yeah, technologies are available, process are known, science is known. Only thing is the economics and scale and mass production or the mass adaptation. That is one of the thing that may take some time, but yeah, it will happen.
So the next question is, do we have all the technical standards in place to be followed for storage and transportation of hydrogen in India? Are these standards similar to what we have in Japan or US?
So there are different agencies in India which are working towards the standards. If it comes to automotive, like ARAI, they are working towards it. PESO for pressure vessels. So actually, India is targeting towards exporting hydrogen. And when it is towards exporting hydrogen, we have to meet the international standards as well. So many of these standards, there are bodies which are looking after the standards. These are being adopted as per the international standards. And then also some of these are fine-tuned depending upon the Indian requirements. So now it is like much of work is being done in that area. And then many standards are now being developed or being adopted. So a lot of work is going on in that.
There is a follow-up question of Pratham, which was regarding the ramping of the electrolyzer. He was saying that he was asking that question because use of electrolyzer system directly for production and directly fueling it to vehicle. Why can't we do that?
Yeah, so actually, just to answer that, that is one of the thing which is being looked into, especially for the ships, where we are looking for, like you'll have a liquid hydrogen, of hydrogen being stored in a liquid form in or some carrier form. So there will be like methanol or ammonia, and say you have ammonia, you can store a lot of fuel in a given space or a given volume. That is what the ship industry is looking for. And then you will have an onboard electrolyzer. So you have the onboard electrolyzer, convert that ammonia to hydrogen, and then use it directly. So that is being looked into. Maybe because the ship has a major issue with storage of sort of a gaseous this thing hydrogen, even at a high pressure, it will not even give it a mileage of 100, 200, or 500 kilometers. It needs in thousands. But once it gets a standardized or technology get safe and reliable and proven, you will see that that will happen in transport vehicles on road as well, because they also need to have a sort of a range at least of say 1,000 kilometers before refilling. So you can store it in some liquid carrier form, reform it on board, and then use it in the engines or fuel cell, whichever way you want to use it. So, but yeah, that is definitely things are going on, and we will see it happening soon.
The next question is like, we have already gravity battery, pumped energy storage, sand battery. Then why we don't consider such energy storage medium? Why we need to go for hydrogen storage?
Yeah, so
green electricity.
just to answer that, see, we require energy in different forms. Energy, though, is a single term, but I would just say that, say, biomass is or wood or a coal is a fuel. Okay, so you are generating electricity out of it, you are cooking fuel or cooking food using wood. But if I ask you, can you run your vehicle? Can you run your car on coal or wood? Then obviously, answer is no. You can't do that. Can you run your fan on coal or wood? No, you can't do that. So different application requires energy in different form. So when you say a pumped storage, energy fast storage, it is one of the cheaper and way of storing, but for that you need to have a sort of a huge dam reservoir, and it is you can say sustainable or good only where you already have a dam and it is already been implemented. So in India itself, we have couple of dams who have tested it and are increasing its capacity. Like in Maharashtra, Koyna Dam has already implemented. So because they have a huge reservoir, now you can do this pumping, reverse pumping, and using it for electricity generation. Daytime, when you have solar, you pump it back to your reservoir. But if you want to create a new dam reservoir for that, then it will not be cost effective. But if you, whatever hydro power stations you have, you use it to full capacity for the reverse pump, sort of a reverse pump storage as a sort of a storage device. Same thing with the sand battery. It is used for when you want heat. So it has been used in Finland. It has been demonstrated for town heating system. So when you want to use heat as a sort of a energy, then it is good. But you can't use sort of a different type of a fuel or different thing for each and every energy application. Though electricity is one of the most versatile, but that also has limitation. So for different type, for whenever you need to replace gaseous or chemical fuel or gaseous or liquid fuel, then hydrogen is one of a very great technique. And also apart from that, there are many, apart from energy, the usage of hydrogen which can replace dirty carbon from the steel manufacturing. So it can be used as a chemical. It will not be a sort of a fuel there, but it will be a chemical which will replace carbon to reduce your iron from your iron ore. So there hydrogen has a role. Other sand batteries and other things may not help it. And other thing is, say for the chemicals, like you are making fertilizer. Fertilizer, you need hydrogen. So can you use green hydrogen for that so that your fertilizer industry can become more sustainable and carbon neutral? So hydrogen finds its usage in multiple areas, but yeah, sand batteries or your pumped hydrogen water storage and all, it finds in a different area, and definitely all of them are not competing, but it's like complementing. So whenever we see such technologies, we should see that they are complementing each other, just like we have existence of coal, petrol, diesel, natural gas, nuclear, water, means hydropower, everything for almost a century. They have been coexisted. Not that one technology has killed other technology. They coexist, and same way we see that hydrogen will coexist with other form of storage. I hope it answers your question.
Actually, there's a follow-up question. I guess a high quality heat will be required for heating those hydrogen carriers. So you answered in context of ship.
Yeah. So only thing is like whenever you need a sort of a high temperature, it's not very high temperature. And see, when somebody looks into this temperature range and all, I would say that marine industry or even automobile and all, we are handling the engines where the combustion is going out at temperature, we are reaching 1200, 1300 degrees. Even your whole engine block is at 700, 800 degrees. So when we have such temperatures, it's not very difficult to design something which can give you heat for removing sort of a hydrogen from your storage tank and all. Compared to that industry or the automobile industry or the marine industry or applications are used to that high temperature. For them, this temperature is nothing actually. So not from the safety perspective or design perspective or efficiency and all, everything such efficient system can be designed and used.
What is the term gold hydrogen?
Most hydrogen, at least I have not heard.
No, I exactly don't remember at present.
I
We
have
will
read
get back.
papers, but what it is.
At present, I'm not recalling. Maybe we will answer it.
The next question is there any blue hydrogen plant in India integrated with CCUS?
So IUCL, they have adopted certain technologies to compare. So it is not an existing plant, but all these are like at present being
In pilot stage.
pilot scale.
Not on 100% overall, but yeah, on pilot scale to see its feasibility, reliability, and cost effectiveness. So it's in the pilot scale, it is going on.
Hydrogen is colorless and odorless fuel. What are the safety measures which are efficient at industry level? If we look, concern of safety starts from production itself. Please put up some light on this.
I would suggest you have to wait because we have an entire dedicated section on hydrogen safety. We will talk about what are the properties which could be challenging, how these are being taken care of. So this is a complete section on hydrogen safety. You will get more idea about it rather than me telling here in minimum number of words.
There is again a follow-up question by Pratibha. Then it will be whatever we are using.
Yeah.
Will it be green hydrogen or not?
Yeah, so actually it depends. Like as ma'am said, that in India, the policy suggests that if your carbon dioxide emission for per kg of hydrogen production is less than 2 kg, then technically it will be classified as a green hydrogen. So if it doesn't meet that criteria, definitely it will not be a green hydrogen. So it is as simple as that.
Will there be any safety integrity level of hydrogen production equipment? Any hazardous area around hydrogen production unit?
I think that is related to safety.
Yeah,
related.
it will cover.
And there is a question, can you add one lecture for metal hydride compression based methods in detail?
Metal hydride based in detail, because this is a rerun course. In this, it's already recorded one, but for new future course, we will keep this in mind.
And also sometimes it's a sort of a hydrogen or overall broad perspective. So production, utilization, safety, and everything has to be covered. So sometimes giving more focus on one technology or one process may be a bit difficult, but yeah, I think in future can be.
We can have specific course related to maybe storage. Or other. At present, we cannot see any question there. Then we can pick up from the discussion forum.
So the question is that biomass in India is huge, but all are mixed and wet, having 70% of water except paddy straw. With its actual available from screening and segregation or any treatment can help in making it viable for harnessing energy or biogas or hydrogen. So I would say that it is not sort of a correct fact. So typically most of the agriculture waste that we get is reasonably dry, less than 20% of moisture level. When you say 70% is like our human body. So we are not, plants don't have that much of sort of water content except this algae and all. But typically 40-50% maximum if it is like a leafy sort of a waste or something. But if it is a woody waste or like a straw dust or dead plants like paddy straw, not only paddy straw, but the wheat straw will also have the same moisture, 10-15% once we harvest it. And same thing for the cotton stalk, it will have even less than 10% moisture. So all these dry stalk agriculture waste have less moisture, which can be easily be used. And the other part of the question is like, can these be used for making biogas or hydrogen? So yes. So when you say about the biogas, then one of the requirement is that it should have, because it uses a lot of water into it. So whichever biomass has high content of moisture in it is preferably goes to biomethanation. But biomethanation, because it's a biological process and bacteria or microbes are quite selective in that way. Bacteria will not digest each and everything, especially the lignin. We still haven't found any controlled way how to digest lignin in such reactors. But yeah, the second generation biomethanation. So the second generation biomethanation, a lot of work has gone into it. And now most of this agriculture waste, which will have cellulose and hemicellulose, that can be digested in the biogas plant. But yeah, if it is a dry, it is suggested to use in the combustion or gasification process to get hydrogen or any other heat or something. If it is wet, then it is advisable to use it in a biomethanation plant to get biogas. So it is sort of that way we can use it. So maybe one more question I will take is, yeah, so which component of biomass can be utilized for bioethanol generation? Cellulose, simple sugars, or lignin or fatty acids? Again, as I said, microbes are quite selective in nature. So if you feed sort of a ethanol generating bacteria like yeast, feed them fat, they will not give you ethanol. So they need simple sugars. So simple sugars, but yeah, the second generation ethanol process have been developed, which can even convert sort of a high grade of carbohydrates, which are not simple sugars, but higher carbohydrates, fibers, cellulose, hemicellulose, part of hemicellulose, which can be converted to pentose sugar through hydrolysis process externally, separately. That is not biological, but separately heat treatment is done, broken down into simple form, which two different strain of microbes convert it to ethanol then. So, but not everything like fatty acids or lignin, basically they won't convert. Still, we have not found right bacteria or microbes for that. But yes, cellulose and simple sugars can be converted through 1G and 2G process. The second part is, however, this is obtained by breakdown of cellulose. This thing, are simple sugars also present additionally, so that we can say simple sugars are present by absence of cellulose as well? Please advise. So as I said, there are two processes. The old method, traditional, which like human civilization has mastered thousands of years back, that is the liquor making. So using simple sugars to make ethanol. So yeast is already there. And then when we say cellulose, so first cellulose, we have to break it down. So that is the process called hydrolysis. And it is simply what we do during the cooking. So you take rice, you add water and you heat it. You will get a sort of a soft. And when you dry it, you won't get the same amount of water back, because water has actually reacted with the cellulose or the carbohydrates in the rice and changed the structure of those biochemicals or biomolecules. So that is typically called the hydrolysis. Whenever we cook food using water, whether it is dal or rice or anything like that, hydrolysis is one of the major chemical reaction that goes in that. What happens is the large molecules or hydrocarbon chains or carbohydrates or cellulose, they break down to smaller chain, and hydrogen hydrogen from the water goes and joins it. That's why it is called hydrolysis. Then once it is broken down to a simple thing, it is easier for the microbes to digest it and generate ethanol. Same like us. If you eat raw rice, you will not be able to digest it completely. So you will be sort of deficient in the nutrients. But when you cook it, you can easily digest it. And that's why we cook the food to get maximum out of it. Otherwise, not more than 15-20% of the raw food we will be able to digest. But when it is like a fruit, it has a lot of simple sugars, not tough carbohydrates like rice or wheat. We can digest it without even cooking. Same thing for the microbes. You cook the food outside, that is called hydrolysis, then feed it to the microbes, then they will be able to convert it into ethanol. And that is called the second generation bioethanol processing. And that is very well sort of standardized, mature technology. There are a lot of plants already running, which uses the sort of a wheat or other sort of a grain material to convert it to ethanol.
Then there is a request. In future, can you please add some course in hybrid mode also for hydrogen production to have hands-on experience? So as being done at IT Madras.
We have been organizing courses. These are like earlier we were organizing these in online mode, but these are specifically targeted for certain industries or like the PSUs, wherein they can come, and also if you are associated with PSUs, then you can join that course. More information we could send to you.
And also maybe in future, like we organize some workshops where we have sort of a physical presence of all the participants. But yeah, for the whole course, conducting these workshops are difficult. But yeah, in this workshop, we also have this lab courses, like we showcase our labs and explain in detail. Physically presence always helps in a bit in some sense. But yeah, this is like a typical 40 credit course, sort of equivalent to that. So that running in hybrid and getting all the students who are attending this course to the campus, we will have to think. Definitely, it's a very good suggestion, but definitely we will have to think and do the things differently to make it possible.
Can we produce hydrogen by pyrolysis of plastic waste?
Yeah, so we can do that, and actually we are doing that. So we are doing R&D on biomass plus plastic waste gasification. So in general, when we say plastic has more hydrogen content chemically compared to biomass, so biomass 1 kg will have hardly 50 to 60 grams of hydrogen. But when we look into plastic waste, 1 kg of plastic will have around 150 to 200 grams of hydrogen element present in that. And it is actually a very good source for that. So one thing is pyrolysis is done, and then reforming of that bio oil. So when we convert the solid plastic to liquid bio oil through pyrolysis, and then some gases are also present which are also reformed, then it is reformed similar to steam reformation is done. And with the steam reformation, hydrogen is one of the major product for that. So process is known, science is known, but only thing is again economics. So economics is one of the issue, but yeah, we are trying to do it in sort of a, you can say, a hybrid mode, plastic plus biomass, which improves its economics. Plastic biomass gasification to give us hydrogen that will have more hydrogen compared to only biomass. So that thing is there, but only plastic pyrolysis for hydrogen production process is known, but market wise, you will not see any plant like that or even on pilot scale because economics doesn't support. So, any more questions from anyone?
So if you have, so we have few more minutes left. If you have any other question or doubt, you can please type into the chat box.
There was a question on so working on a solar industry, doing this course to acquire some knowledge. So solar power generation.
So this is on to the solar integration with electrolyzer. So as we already know, with the National Hydrogen Mission, a lot of push is there into the green hydrogen. And PLI schemes, a lot of incentives which are being associated with electrolyzer indigenization towards electrolyzer manufacturing and green hydrogen production. So there are already advancements in this area. And there were, in fact, bids being called and announced at times regarding these, and where different companies, industries have participated into those. And there are different measures which are already going on, lot of interest globally, because they see India as a market, and lot of interest towards manufacturing, to start manufacturing in India, different components and electrolyzer stack as well. So there is lot of things which are currently going on for indigenous development of electrolyzer in the country.
Can we be able to perform electrolysis of a natural gas?
Yeah, so actually, a lot of things is going on in that area. Electrolysis of different type of gas. So one technology, which is the solid oxide sort of technology, solid oxide fuel cell are there, electrolyzers are there. And people are looking into electrolysis of natural gas as well as liquid fuels like methane and ammonia. And that sort of a thing, not exactly sometimes electrolysis, but the reforming of that to get hydrogen. I think natural gas electrolysis. One thing which means research is going on. It is not, I would not say that it is in even in the demonstration stage or something. One of the major requirement or the demand is stripping the carbon out of methane or the natural gas. So if you can strip out the carbon out of it as a solid, and then convert it into hydrogen pure and get the solid carbon out and put it back into earth. So it will be like as good as a green hydrogen. So that is a sort of a philosophy that many people are working on. So electrolysis or combined electrolysis and pyrolysis that is going on, people are using, I won't say this electrolysis is similar to how you do water electrolysis, but yeah, using the electricity or the electric potential plus heat combined together to strip or break the bonds to get the carbon in the solid form. It will come out as solid, and hydrogen as a gas will come out, and you get the hydrogen, which will be very good, as good as green hydrogen. So, but yeah, a lot of R&D is going on in that area. Hopefully, it will come out. So it will be very again good, cheap mass source of green hydrogen.
There is one student, yes, Kapshikar. He is saying, I am currently an intern at IIT Bombay.
Yeah, so
Yes.
Why don't you come and meet?
Yeah. So please send an email. We will give you a time, and then you can.
Okay, thank you. I hope we have answered all your queries. And so for after a couple of more weeks, we will have again another doubt clearing session like this live session. And you can also keep writing on discussion forum. There also we will try to answer all your questions. Okay, thank you. Thank you for joining this session.
Thank you. Thank you, everyone. बच्चे